Good. So another nice and straightforward video, which should be one here. We're going over section 5.4. We're going over how we can solve rational equations. Okay, so I'll give you a bit of a procedure here as we work through, and you will see how the procedure allows it to line up with how we know how to solve equations from our previous lessons and our previous courses. Okay, so right off the start, we now know a rational equation can be recognized by the presence of variables or a variable in the denominator. We are typically using x as our variable when we're working algebraically, but if there is a problem that is an application problem that we're going to try and solve, we might be using another variable. When we're solving these, we're going to start off by stating our restrictions. That will give us the freedom to manipulate the equations, perhaps simplify them so that we no longer have any denominators. Then we can rewrite the expressions, each one, so that they have a common denominator before we can get rid of that denominator entirely and solve the equation in the numerator. You will see what that looks like as we go forward here. We'll start off with example 1. I'll leave that list here right at the top. Start off with example 1. We have a rational expression on the left side of our equal sign and a rational expression on the right side of our equal sign. Right away, we can find our restrictions. Our restrictions come from the denominators. The restrictions come from the roots of the denominators, right? We're not allowed to divide by zero, so we need to find the x values that would make us divide by 0 so that we can say, okay, we cannot have those x values. Right away, my left-hand side, okay, there's only a simple x there, so my restriction x cannot equal 0. Nice and easy. Okay, now what about my right side? Well, x minus 4 is not allowed to equal 0. Is not allowed to equal 0, so I can rearrange this. X cannot equal positive 4. Okay, so my two restrictions that I would list right here, and let's move that over for ourselves. We'll just put that down there. It shouldn't be in our way. And we can write here our restrictions. X cannot equal 0 or 4. Awesome. Okay, now let's move forward. Now that we have stated our restrictions, now we're allowed to manipulate the problem so that we can maybe even get rid of our denominators. Okay, that's our goal, is to solve the problem without denominators, because denominators complicate things. We will, you'll see we're not always able to get rid of a denominator. You'll see in section 5.5, but in this section we will be able to. So now we need to find a common denominator. Well, I have x over here, x minus 4, so my common denominator, nice and easy. Maybe I can even write that down here. Common denominator is x times x minus 4. Nice and easy. Okay, so I can work right down from here, and I can multiply my left-hand side by x minus 4. So that I'm working with x times x minus 4. Sorry, I'm multiplying it by x minus 4 over x minus 4, right? 6 times x minus 4. Multiply my right-hand side by an x, so that's 3x divided by x times x minus 4. Good. Now I want to solve the equation in the numerator. Okay, what that really means is that I'm multiplying out my common denominator. So it's like I multiply both sides here. Let's go with a different color. It's like I multiply both sides here by x times x minus 4. Okay, it's like I multiply both sides by that. Well, if I multiply both sides by something like that, what can I do? I can quickly cancel out my denominators on both sides. Really, what I can do, once I get a little bit more used to this, is I can just realize that I will be multiplying both sides by that common denominator, so I can rewrite this equation without their denominators. So I could write 6 times x minus 4 equals 3x. All of a sudden, this problem looks far simpler, right? It's nice and straightforward. That is 6 times x minus 24 equals 3x. I can rearrange that, subtract 3x from both sides. I'm working with 3x on the left-hand side. I can add 24 to both sides, so 3x equals 24, and that is x equals 8. Okay, so here I would say, therefore, x equals 8. And then I need to double check. Okay, so I've solved the equation in the numerator. I need to check my restrictions that I began with. Right? So I check my restrictions, x cannot equal 0 or 4. Well, that's fine. That's not the solution I found. So my solution holds true. Okay, x equals 8, that is the solution. That will not always be the case. Sometimes some of our solutions, and you'll see as we work with higher degree problems, we'll have more than one solution. Some of our solutions will be admissible and some of them will not be from those restrictions. Okay, so now we'll try, what I encourage you to do right here is pause the video, try out that exact same strategy with example 1b here. If you're able to get through the whole thing, fantastic. You're in a really good spot, then you can move on to C and D. But if you get stuck at some point, then unpause the video, find that spot, and see how we're doing it. I'll go about it right here. The very first thing I do is I find the restrictions, right? So I state all of the restrictions. I can rewrite this. If I'm going to do that, really, if I'm finding restrictions, I'm finding which values of x would make this, would make me be dividing by 0 at one point. If I'm trying to find the restrictions, I'm trying to find the roots of my denominator. Trying to find the roots of my denominators, what will help me is factoring these denominators. So I'm working with x divided by x plus 2. That's already factored, plus 16 divided by, and I can factor this here, x plus 2, x minus 2, equals 4 divided by x minus 2. Awesome. Now it's a little bit easier and I can say, okay, I can find my restrictions. I'll go with another color here. I can find my restrictions. I notice here that I see this, I see the same two factors appearing together here. My restrictions can be found from setting those factors equal to 0. So x minus 2 equals 0, which means x, cannot equal 0, which means x cannot equal positive 2. And then x plus 2 cannot equal 0. So that means x cannot equal negative 2. Please forgive my cannot equal signs. I know they're inconsistent. That's okay. All right, so my two restrictions, x cannot equal plus or minus 2. Fantastic. Now let's keep working here. All right, I've stated my restrictions. As I move forward, I'm trying to multiply everything by that common denominator, or rather give everything the common denominator. So I'm multiplying my right-hand side, 4x minus 2, by x plus 2 divided by x minus 2, right? x plus 2 divided by x plus 2. I'm multiplying my one term here by x minus 2 divided by x minus 2. So that is x minus 2 divided by x minus 2 times x divided by x plus 2. And that's okay without the brackets over the top. Plus 16 divided by, well, this already has the common denominator, so there's no need to multiply anything in here. X plus 2, x minus 2. Okay, well, now we can use the shortcut that we found about last time. Now that we have everything written with a common denominator, we can just cross out all of those denominators themselves, leaving me with a much simpler problem. X minus 2 times x plus 16 equals 4 times x plus 2. Okay, now if I'm going to solve this, I've been solving problems like this since grade 10. We know how to do it. We distribute our problems here. So we're working with 4x plus 8 on my right-hand side. On my left-hand side, that is x squared minus 2x plus 16. I'm collecting my like terms. I'll collect everything on the left-hand side here. So x squared minus 6x plus 8. All right, nice and easy. If I'm working with x squared minus 6x plus 8, I can factor this using my grade 10 factoring skills. That's x minus 4, x minus 2. Fantastic. Therefore, x equals positive 4, right? So if I set each factor equal to 0, positive 4 or positive 2. Awesome. Well done, us. We're all finished. We solved that nice and easily. No, we didn't. Hang on. We need to double check with our restrictions. Right? X is not allowed to equal plus or minus 2. So x must equal only 4. That is a single solution to this problem. X equals 2 is not a solution because that one is inadmissible. It's not allowed from our restrictions. Okay, lastly, what I will do here, folks, I think that's enough. You folks should be able to handle the rest. I will post the solutions. Whoops. What I'm going to do, though, for you, you know what? I'll go over one more in here because it's been a pretty short video so far. We'll go over, let's see, what color do we want to work with? We'll go with gray. We're going to solve C. I'll leave D for you. The solution will be posted. And then the second page, we're going to spend time in class going over. All right, the application questions on the second page we'll spend time in class going over. So let's take a look here. We start off, we find our restrictions. And in fact, if we're finding restrictions right away, we work with another color. Our restrictions are x cannot equal -1. You'll notice I'm going a little bit faster here with my restrictions because now we're used to it. X cannot equal -1 and x cannot equal 0, right, from this fraction over here. Fantastic. Then we can work on a little bit forward here and we can give everything a common denominator. So I need to multiply this first fraction by x plus 1 divided by x plus 1. So that's x plus 1 divided by x plus 1. Remember, we're allowed to do something like this because this is a fancy version of 1, right? Anything divided by itself equals 1. We're allowed to multiply that in. So x plus 1 divided by x plus 1 times 3 divided by x plus 4. And here I'm multiplying this fraction by x over x. So plus 4x divided by x times x plus 1 equals 2, and here I need to multiply the numerator and denominator by the same thing here, and that's my entire common factor. So that's x times x plus 1 divided by x times x plus 1. The most common mistake folks would make right here would be forgetting to multiply their right-hand side by this common denominator. But now that we've done that, we can see every single part of this function shares the common denominator. We can cancel out these common denominators, leaving us with a much simpler problem that we know how to solve, and that is 2x times x plus 1 on my right-hand side, x plus 1 times 3 plus 4x on my left-hand side. Again, I need to distribute so that I can expand into a standard form before factoring it. So we're working with 2x squared plus 2x on the right-hand side here. I'm working with 3x plus 3 plus 4x on the left-hand side here. I'll collect all of my terms on the right-hand side. You should be able to solve the rest of this on your own. That is 2x squared plus 2x minus 7x, so that's minus 5x minus 3. Now we can see right away we can factor this using, again, our grade 10 skills. We do not need to use the quadratic formula here. You should be able to work with your, I can't think of the right word right now. Disconfiguration is what's coming to my mind, but I know that's not right. Decomposition. It took me far longer to remember that word than it should have. But either way, whoops, we can factor this here. We're working with something like 2x plus 1 times x minus 3. And that's fantastic. That tells us our final answers. X equals positive 3. X equals -1/2. And then we need to check, right? We need to check with those restrictions we had. Luckily, x equaling positive 3 or -1/2. Both of these are plausible solutions. So therefore, x equals -1/2 or x equals 3. Again, for solving 1D, you should be able to handle that one on your own. I will post the solution on our classroom so that you have access to it. And folks, you know what? I'm looking here right now and I can see I copied this wrong. So on your own page, you'll see a different question here with its solution there for you. And like I said, examples 2 and 3 we'll go over in class.